So good afternoon, everyone. It's Anubhi Khandelwal. I am the Digitalised Automation Specialist for Siemens Digital Industries based here in UK, in Manchester. So this is our last session of the digital week. We'll be going over a machine simulation. So as James said, we covered the separate bits. This week on Monday, we did the automation, so PLC Sim Advanced. On Tuesday, we did Simmet. On Wednesday, we did NXM Mechatronics Concept Designer. So those three products we went through, and today we will see how all three of them, they come together and we can have an end-to-end virtual commissioning. So the agenda for today would follow as we'll have an overview of virtual commissioning, so what it actually means in a use case. And then we will have some tips and tricks on how to get started with it, how to quickly create some couplings in Simmet, how to bring different software together. And then we will have a live demo. And after that, we will also have a look at a machine, our DigiDemo machine that now sits in Manchester Digital Experience Center. And we had created the digital twin of that machine before we had it in our demo room. And so I'm going to show that as well at the end. Okay, so moving on. Before I start, I'd like to mention here, last week we also had the session at Commissioning from Couch, which was one of our Tech Talk session last Friday. So if you want to watch it, it's available to be watched on demand on the same site where you registered for this talk. So please go on there and have a look at it if you're interested. Right, so as I just mentioned earlier, the three components to create a complete digital twin. So NXM MCD for the mechanical components, Simmet for the peripheral devices like drives, valves, etc., and PLC Sim Advanced for the the automation program basically. And we'll see how these three are coming together. But what does that actually mean in the real sense? So I can see there's a bit of a lag here. Okay, so on the automation system, we have our controller that sits there. Now, Simmet is simulating electrical elements, which means, for instance, a drive. So my controller sends some commands to my drives. My drive then sends those commands to the motor that sits in my machine. So that's my mechanical system. Then say from my encoder, some feedback comes to my drive, and then drive packages it in a nice telegram or a hardwire and sends it back to my automation system. So that's my complete communication, how different elements, they talk to each other. And when I want to virtually commission it, I have PLC Sim Advanced. So for instance, if I use something called a technology object to commission and configure my drives, so I can do that. I can say have a positioning axis, so I can control the position of my motor. I can give some set speed point and in the form of a telegram. So all this set point that goes to my drive now, that's being simulated in Simmet. So what we see here are blocks. They are from the library, Simmet library, and we can literally drag and drop, and we can start connecting the inputs and outputs from your PLC and from your machine or MCD. So once this is simulating the drive, it gives the set speed point to now what sits in MCD. So as we saw yesterday, we can quickly give some kinematics to our machine in MCD. So speed control is one of them. We can give the set speed to that control, and we can read the actual speed back again to the drive like we would read from an actual encoder, and then feed that back in the telegram format back to my automation side, back to my controller. And this is what we will see today, what's going to happen. Right, so I will then jump to my first demo. Okay, so what we see here is Simmet. It's just completely blank project from scratch, doesn't have anything at all. Michael did a proper deep dive in Simmet on Tuesday. So if you're interested to know more about Simmet, please go back to the site and you can watch the on-demand session. So for now, we will see how we can quickly create some couplings and create some charts automatically. So it's the minimization of efforts now, which we will be seeing in a bit. Before I go on creating couplings, I will show you my TIA portal project. So I just have one 1500 CPU. I have two drives, one G120 and one S210. And if I look in my program under technology objects, you can see I have two technology objects. One is the speed axis and one is the positioning axis. So the speed axis to control the speed of, say, a conveyor, and position axis could be, say, for an arm of the robot or some pusher plate or something like that. So we can have these technology objects to control those things. And in terms of MCD, for instance, there is a bit of a lag, so I'm trying to keep on to that. Actually, a lot of lag. Okay, let's see if it jumps to MCD. Okay, now we can see MCD on the screen. So this is my conveyor. This is exactly what we worked on yesterday. So if you saw yesterday's session, you would be familiar with it. I've just got two conveyors. I've got the speed control for my conveyors. And I've just got a SCARA robot, so that could do some sort of a pick and place operation. So right now we will just see how I can have a drive just controlling one of the conveyors, for instance, or controlling one of the speed controls that sit now in MCD. So I will jump back to Simmet. Okay, to create a new coupling, we have something called new couplings, and you can see we have loads of options. So Simmet unit, if you wanted to connect to an actual hardware, so you can connect to the controllers or the field devices. You can use Simmet unit for that. PLC Sim Advanced to directly connect to your TIA project to PLC Sim Advanced. Then we can have OPC UA couplings, shared memory, and a direct MCD coupling. We also can have couplings to virtual robot controllers of KUKA, Stobly, and Denso, and many more that are coming up. So if we want to create a PLC Sim Advanced coupling, I click on that, I say okay. Now there are two options. I can either directly link to wherever my TIA portal project sits, or I can have an hardware export file. So in this example, we'll have a look at how we can use a hardware and config exporter. So there's a tool available to download from support side, HWCN export tool, and this basically allows us to export the hardware configuration of your TIA portal project. So if I double click on this, you can see I select step 7 TIA portal and I can browse to wherever my file sits. So for instance, this one, and I can tell it wherever I want to save it, and I can just click on create XML, and that creates the hardware configuration file, the XML file for me. I won't do it now because it takes a few minutes to do that. So I just close it, and if I go back, you will see that I already have a file created here for the hardware configuration, giving it some weird name, ABC. So if I go in HWCN, I just click and I select my XML file, open it, and I import it. So when I do it, you can see that now one station is created for me, PLC Sim Advanced station. I can go in distribution, and down here we can have different sorts of communication interface. So it's soft bus if everything is on the same machine, but we can also have TCP/IP if we are having distributed instance, so we can do that as well. And we can have a look at all the IOs that are being pulled from my project. So I'll wait for it to come up on the screen. Yeah. So you can see the actual IOs that exist as an IO card on my hardware configuration, and some positioning axis and the speed axis. So everything that I created in my project is pulled directly in Simmet. But it does not create any tags for internal DBs or memory bits, because it's the actual hardware IOs that we are trying to simulate. Right, so we can also create coupling for MCD. Okay, and I can link it directly. So there's an option on top to link it to wherever my file sits. And let's link it to that. Open and link. So it takes just a couple of minutes to bring all the parameters associated with all my kinematic objects that sit in MCD. So we had some speed control or position control or any joints. So you can see all of that is now pulled in form of inputs and outputs. So some stuff that's going from my controller as a control set point to my MCD, and then some feedback that's coming back from MCD. So that could be the actual positions of my arms or my conveyors, or some sensors that are giving me some sort of feedback. So I quickly create some couplings, and now I can create some charts. So this is like now a blank chart, and I can make a use of this extensive library that to create my simulation model. Again, Michael explained these libraries in detail on Tuesday, so I will not go in detail, but mainly in this use case, we are looking at drives. So I will, so these are the library blocks that are available. We can create different telegrams by mixing and matching different blocks. So telegram 1 on 3 or 105. And we also have a dedicated drives library available on our support site to download. So if you can download from there, and we can drag and drop. So it's a matter of dragging and dropping. This is all well and good, and I'll have to drag and drop it, and then I have to go in signals here on the bottom right corner and start doing the mapping. So it's a bit of a manual task, but now it's all been automated for us, so we really don't have to do all of that. With TIA Portal version 16, we have an option to do this automated engineering, and that uses the openness. So if I go back in my TIA Portal projects, as an add-in, there's an add-in available now called Simulation Model Generator, and it basically creates a model for all the technology objects that exist in my project. So right now I have 2 technology objects, so it should basically create, when I say 2 technology objects, I mean 2 drives, so it must create 2 drives for me within Simmet. So I can go and right click on it. I can go and say Simulation Model Generator, as you see in the bottom here, and generate multiple models. And when I do that, it pops this box for me. Just wait for it to come through. And there we go, almost. Okay. So now here I can choose what station I'm looking at. Right now I only have 1 CPU, but I could have had multiple CPUs. So I can select multiple if I had a different station. I can choose to select either one file for all the drives, or I can choose to select different files for different drives. Then I can choose what folder I want to save it in. So for instance, somewhere in demo I want to save it, and what version of Simmet I'm using. And I can say start creation. So when I do that, it starts creating a file for me again that I can import in Simmet directly. So I'll just cancel it because it'll take a few seconds. I already have it with me. So then I can go back in my Simmet projects, and there is something called automatic modeling. So you go on top, you do automated import, and this is the file that was created for me using the tool. So I say open, import. And when I do that, it basically creates, you see we have now 2 charts that are created by my automatic model generator. One for the speed axis and one for the positioning axis. So for positioning axis, I was using Telegram 105. So you can see there are more blocks here, different blocks. And for speed axis, just 1 Telegram, so just one block here. And all my PLC TIA tags are automatically tagged into this, so I don't have to do anything. All I need to do is just connect it to my MCD. So we know the MCD tags that exist in my signal table here. So I can say my set sheets. I keep forgetting there's a bit of a lag. And I can drag it, drop it, and just link it like that. And similarly, I can have some sort of a speed feedback, which is my input coming back from my MCD and going into my drive block. So this is your chart created for you now. It's ready to go, and I can just play and start testing my technology objects, start commissioning my drives using the commissioning wizard that's available on our, that's also a possibility. and we can start some basic testings. Okay, so this was the first bit where we had a look at how quickly we can create some couplings, we can quickly create chart, and most of the work was anyway done for us in this particular use case. Obviously, Simmet, PLC Sim Advanced and MCD on their own, they can do a lot more than just drives. As you know, there's this extensive library for different pumps, valves, motors, a complete library for conveyors as well. Okay, so we will now go back and have a look at one of the live demos. Let me close this. And okay, I will wait for the screen to come up again. It is again a bit of a lag. So I am looking at a pick and place packaging machine now. It's got one robot that sits in center, picks some trays from one of the conveyors, puts it on this conveyor, picks some boxes on another conveyor, puts on top of that, and then that goes further down, and then there's a Cartesian picker which sort of does some sort of drilling or something, and the product goes further down. So we created all of this in NX, and if you attended yesterday's session, you know we can very quickly start giving some using inverse kinematics, we can quickly start configuring our robots. So if I just scroll down a bit, you would see I have inverse kinematics here for both of them, for my 6-axis robot and also for my 4-axis. And let's have a look at the TI portal project. See that lag is getting bigger and bigger now. Okay, so in my TI portal project, again, we've got a 1500 CPU, I've got a comfort panel, some remote IOs, and then again 2 drives for 2 conveyors, and one RFID device as well. So we are now using RFIDs and safety in this example. Quickly we'll show you what exists in my technology objects. Again, I've got 2 positioning axes for 2 conveyors and 1 CO for my RFID. And my Simmet model, I have got 1 chart for my RFID simulation. So this is again directly from a library that exists on our support side. We can download the RFID library and we can start quickly simulating different RFID. And in Simmet, we can, in safety, we can see that there is this block called FTI. So this is basically for the safe IOs. There's again another library that exists on our support side, free to download, and it's for 8 input channels or a 16 channel or 12 channel, and we also have for safe outputs and safe analog inputs. So these are available to be downloaded from our website and ready to go. So what we can see here, if I go in projects, we can do different parameter settings for my safety block. So I can see that for all the channels, I can either have 1-on-1 evaluation or I can have 1-on-2 evaluation. I can define what sort of passivation I'm looking at, so whether it's a channel passivation or the module passivation, and I can define what sort of inputs are coming. So some inputs are coming directly from MCD, some inputs are coming from PLC, and some are being activated using Simmet. So we can also have some push buttons and some switches inside Simmet. So this block, for instance, the emergency push button, it comes from the control library, and we can use this to activate some emergency stops. And similarly, this comes from our control library as well, so we can see what's the status of our maybe safe BIOS, for instance. And we can see all these are then going back either to PLC, or these are the value status bits or the QBAD, if you like, that can be fed back to PLC as a feedback that my channel is healthy, there's no problem with the channel. Plus, we have more charts for mic drives again for the two conveyors as we saw earlier, and you probably would recognize this structure now for the telegrams. Okay, so now I am in simulation, and let's see, let's begin some basic testings then. So right now, if I try to play anything, nothing will happen, because I can enable my stop and nothing will happen, so I have to disable it, and we can see the change of light that it's okay now. I can then just acknowledge and when I acknowledge it, it goes green, which means it's all healthy and ready to go. And let's have a look at our MCD then, and I can use one nicely written HMI to start controlling it. So I can power on my robot and I can select the job I want to do. So maybe I say go on the tray, and when I do that, it goes on the tray. I'll wait for it to catch up with whatever I said. It's just a bit of a lag. And similarly, I can handle the conveyors. So there's manual control for the conveyors. Okay, I can choose for the conveyors now. I can turn them on, and when I start doing that, my boxes start, my products start coming down the conveyors as well. God, this is really struggling to catch up. Okay, almost there, almost catching up. I guess it's just a bad internet. So, well, we see it can move manually now, so I can try to move it in the automatic mode, and I can see, for instance, it performs some sort of sequence in automatic mode, so it goes and picks up the tray from one of the conveyors, and all the parts that are coming down this conveyor, they go through some sensors, so they can possibly be some RFID sensors, which we can then simulate in Simmet as we saw earlier, and we can give those feedback to PLC. So if I start my automatic mode, we see that the product starts coming down, and my robot will perform some sort of a pick and place operation. And if I go back in my Simmet now, I can, back in my HMI, I can go in my RFID and I can see loads of values that are coming back. So I can read some value, I can write some values, and they're all being simulated within within Simmet for RFID. What I can also do is I can try to introduce some channel faults, and I can see how my how NX reacts to those channel faults or my sequence. So let's say if I introduce a fault in my channel 1, and go back to this, it's just now probably it's just stopped there and it's not going to do anything. So we can now start testing that if we are introducing some channels, how do we want our sequence to operate, whether it should reset or it should follow some sort of safe procedure, safe sequence, any of those stuff. So I can go back, I can remove this failure, I can choose some sort of reset, and I can see with reset again how it's performing. So when I do the reset, it starts working again, but we are now not sure whether it will follow the right sequence or not. So by the looks of it, it doesn't. So there's some problem in the code that needs to be fixed if these sort of errors are introduced. So we have to check all of that. And it's very easy to do this now that we have everything testing and running for us all integrated together. Okay, so this was one example of our light demo for us. And the last bit really now would be to have a look at our DigiDemo machine. Before that, this is how the machine looks like. So we have, this is our demo room, or the Digital Experience Center as I should call it. And this is just a Cartesian pickup There are 6 balls here with different numbers. So when I do when I say press, I say play, the picker goes, opens the door. These balls, they come down in some random sequence, and from my HMI I can enter what sequence I want the picker to go and pick the balls. And the camera here takes a snapshot of the positions of those balls. It feeds back to PLC. Once it does that, my picker starts moving and starts picking the balls from this back to the tray in the same sequence. And my MCD completely mimics the movement of my portal, and also we do some simulation for the camera, and rest of the code is written in TIA portal. We are using Simmet to do the simulation of the 3 drives here, and also some safety simulation. So let's have a look at that. So this is I will wait for it to come through again. Okay, so this is now my CAD drawing for my existing machine. Let's play it, and we can see I have some physics defined here on the left. This was all explained yesterday, how to create some rigid bodies, how to create certain joints. So all of that was done yesterday. If you're interested, please go back and have a look. So now let's have a look in our TIA portal project, and we have 1500 CPU again, and we've got 3 drives for the control of 3 arms. We also have some remote devices and a camera. And let's have a look at what exists in our program. So I can see 3 technology objects, 3 positioning objects for X, Y, and Z, and we also have a kinematic TO where we can define the Cartesian, define this as a Cartesian picker. Now we have our nicely made HMI, and in Simmet we have 3 different charts for 3 drives. We have a chart for positioning of the balls, so it gives us what feedback is coming from MCD, where do my balls sit, and we can have a look during the runtime, what are these values. So I will go back and try to operate the machine using HMI. So this is one classic example of operator training as well, where we can use HMI to start operating the machine even before we have it. So I turn the power on and go back to my ball sequence. I can give any sequence I want, and when I press start, you see that it goes and starts performing the sequence. And there's a lot of lag here, which is not good. But anyway, I wish I could show you what's happening on my screen, which is much nicer and faster than this. So we can see the values of the positions. The positions of the balls are fed back to Simmet, which are then fed back to PLC. And going back to MCD, then we can see it's performing the pick and place as we expected it to in the right sequence, which we can obviously validate. And once it's done that, it would just stop there and wait for the next command. We can also move manually. So this was just the automatic movement, but what if we wanted to jog it manually? So I can possibly give some speed set points. I can enable the axis manually, and I can say, for instance, command it to home. So this home position is again written in as my code sequence in TIA portal, but it's being done manually. It's being enabled manually by using my HMI. I can also use a hardware HMI. We don't have to only use the simulated HMI, so that is an added benefit. And once it's done homing, we can see now the positioning of all of these 3 axes. They would go down to 0, and this means this is all homed now. And then I can start moving the individual axes as well. So if I'm looking at X, for instance, I can see what's the feedback position, where it is, say for Y, and maybe for Z. We also have defined some hardware limit switches in HMI, in MCD, so we can get that as a feedback as well. And if it hits the hardware limit switch, my axis gives me an error that it's gone beyond the limit. Okay, so this was just quickly how we can start commissioning our machine, and just to go into a bit of detail of how we got how we mimic the camera. We wrote some background expressions there to figure out what was the location of the ball because we could not actually simulate the camera anywhere. And I explained yesterday how quickly we can start writing some expressions. And this is it for our DigiDemo machine as well. So going back to my presentation then. Just a few tools for you. There's a compatibility tool available on our support site again, because we are using 3 different software. Sometimes there's issue with compatibility. So we can download from here and figure out what software works with which version of, say, NX or PLC Sim Advanced. We also have a very consolidated page on our support site which has all the examples, application examples for Simmet MCD, which are again free to download, and you can start working around with some basic go-to examples. But how would you do that if you did not have any of the software? And solution for that is our cloud solution, which is somehow spelled CRUD solution. Anyway. It's a 21-day trial for TIA version 15.1, Simmet, NX MCD, and PLC Sim Advanced, along with all the SIOS examples that I just mentioned. So we can go, you can register for this, which will be free for 21 days, and you can start playing around with some of the examples. Okay, so this is it for me for now, and I hand it back to you, James.
Before we dive into any questions, because it might go on a while, just as a reminder, next week is Cybernet week on Tech Talks for the discrete thread. There's, of course, the process thread running in parallel now next week. Here's an overview of what the sessions will be next week, 5 sessions to choose from. So please do go to the website, get registered, and subscribe to what is available. But for now, we will invite Nick and Michael back into our session. Are you online, gentlemen?
Certainly. Can you hear me, James?
I can sure hear you, Michael.
And are you
with us? I can hear you too, Nick. That's fantastic. And just for a treat, we will happily turn on our webcams for you as well, so you get to see the delightful faces of our colleagues here. Good. So yeah, we're welcome to take any questions you might have on the topic of virtual commissioning, anything you've seen over the last couple of days. These are the people to answer your questions. If anyone would like to unmute their microphone. On the fear that no one would ask any questions, I do have some lined up for Nick, Michael, and Anubhi as well. And one I get asked a lot, which I will feed to these 3, is about why digital twin, when digital twin, where do I start? If I'm an end customer, do I now say to my integrators, you must always provide me with a digital twin? And if so, what does that digital twin look like? And if I am a system integrator, do I now have to take all my CAD data and run it through Mechatronics Concept Designer and connect it into Simmet? Is this just the standard thing I now do? So if someone could answer for me that question in terms of where do I start with digital twin, that'd be great.
So as we had a look at our 3 different software right now, usually customers already have some CAD data. So they are designing their machine in, I don't know, maybe SolidWorks or Inventor or any of the CAD drawings solutions basically. So if you've done that, you can directly import it in NX MCD. So it's a very easy import, and we saw that yesterday. Within a few minutes you can import a file. Once you've done that, you can start just creating some kinematics. So yes, you would have to work a bit on all the 3 points, on the 3 topics, but you're already writing your TIA portal project. That's not an added work. You've already created your CAD project. So now it's a term of just integrating them together. So you quickly importing your CAD drawing in NX MCD. You start testing against your TIA portal project, and Simmet now it's because with the automated engineering, your charts can be created for you. So you can start just quickly testing all of that together.
Cool. And I guess ultimately it's about what you want to get out of the digital twin. Would it be, Michael?
Yeah, I would say, James, it should always start with the problem. Like my personal problem was I meet customers and they've heard about digital twin and they just want the digital twin. But then you ask them, why do you need this? What is the driver for you? And they are uncertain. And I think this is a bad place. Like, okay, it's great. The digital twin can help us beyond the problems. But I would always start with a problem. What is the problem? What are you currently struggling with? What issues are you trying to address? And then, see which packages maybe would be the best choice to actually fix this. Because the idea of a holistic approach and fully digital twin is great. It's an amazing idea. But let's be honest, it will consume some time. It will consume some resources. So rather than throwing all our resources at solving the problem that we haven't identified yet, let's identify the problems. Let's identify the pain points. And only then let's actually commit to a solution. Maybe PLC Sim Advanced is all you need with the API. Maybe you should throw Simmet into the mix. Or maybe you need some physics, and this is where MCD comes into play. But do you actually need all three? Will one solve your issues? Let's not overdo. Let's not make problems. Let's just solve problems. But having said that, there are some situations where, the customer never had any problem, but they said, I want a training solution. And this is, I would say, one of these rare occasions where having a full digital twin can be handy, because you can replicate the entire functionality of your machine, of your system, and this can really improve the training procedures, because people can actually train on the virtual thing. They can break it as much as they want, and it's not going to cost you any money if they do so. So I would say this is one of these rare occasions where you would then really benefit from a full digital twin.
Nice. To that point, actually, Michael, where costing of money, Nick, we showed PLC Sim Advanced on Monday. This obviously is a chargeable optional package. Tier Portal already comes with a PLC simulator built in for free. Why would I spend the extra bucks? What's the difference between PLC Sim built into Tier Portal and PLC Sim Advanced?
So for me, the main standout difference is the ability to have PLC Sim Advanced going out onto a network. So that brings in whole new realms of line integration testing. So having the ability for your simulated S7-1500 to maybe talk to SCADA systems, talk to third-party pieces of kit, these are all great things. Now also when you're looking at cost, yes, PLC Sim Advanced is an upfront cost, but we buy it once and then we can roll it on to future projects. Now, in normal PLC Sim, we're quite restricted on the amount of simulated PLCs we can have running concurrently. So with PLC Sim Advanced, we can have up to 16 running on the same box. Now, in everything we've looked at today and all this week, the major factor with all of this is integration. Now, all of this relies on the API of PLC Sim Advanced. So a lot of what we've seen with the Simmet, with the MCD demos, this just isn't feasible with the standard PLC Sim. Now, going back to what Michael and Anubhi were saying on the sort of the costings and why would we go about doing this virtual commissioning, for me, it's also a case of the life cycle of the project. So if we imagine we signed a contract, we need to get our machine out the door by a certain period of time, we get our next payment, machine goes to site, gets commissioned, and eventually we sign it off with our acceptance tests. If we can try and pull these steps back a little bit, get things out the door earlier, we can start to save some money on the costs of our projects. So we've all probably been stung in situations where a machine's 4 weeks overdue, we've got service engineers on site, we're paying hotel bills, we're paying for their meals, customers angry, we might be running up penalty clauses. The whole idea of this virtual commissioning is these pain points, these areas of the machine, these bits where the control system engineers are sat at the panel with a laptop trying to hammer out problems. These are the problems that should have been fixed back in the office. But these are the sort of problems you can't fix in the office because a regular PLC Sim isn't going to give you the feedback from a piece of machinery. So by using the Simmet and the MCD, the guys that are working with these control systems can start to get feedback from the system that we normally wouldn't get until we're in the shop floor commissioning stage. So a lot of this reduction of error, a lot of this reduction of cost just kind of brings the overall cost of our product down.
Or I guess you're stuck at home due to a virus pandemic and can't get near the machine right now, but have a lot of testing to do.
Yeah, very true.
Very true.
On the price point, you mentioned the price of PLC Sim Advanced. It's obviously more expensive than PLC Sim because PLC Sim comes for free with TIA. But what I see customers do, I see them deploying PLC Sim Advanced centrally and having central licenses. So it's not like they need a license per engineer because they deploy it centrally. And if I need to test something, I just connect to the VM that runs centrally even in my central office through a VPN, let's say, I just use the license that's there. So, a single license or 3 licenses can cover multiple people. So it's not like this. You don't need PLC Sim Advanced per engineer. It's just there for when you actually need it.
Yeah, to build on what Michael's saying there as well really quickly. Sorry, James.
Go on.
The latest version of Simmet can also be distributed as well. So that same VM that's centrally running in your office, not only could that be running one instance of, or one version of PLC Sim Advanced with up to 16 PLCs, it could also be running Simmet on it as well. So that could be your central sort of simulation location for all your engineers.
Absolutely. The question actually I received on LinkedIn last night was around simulation with Simmet and MCD. Actually, I'll fire this at you, Michael, I guess. But on Tuesday, Michael, you showed us how we can simulate conveyors in Simmet for testing our applications. On Wednesday, Anubhi showed us how we can simulate conveyors in MCD with boxes moving down them. Which one's the right way to go in terms of simulation of conveyors? Do I use Simmet? Do I use MCD? This customer was messaging me about it.
It's the same question all over again. What is your problem? What are you trying to solve? Because Simmet and MCD, they are different packages. They complement each other, but they are different packages. That's why they work great in conjunction. So, okay, I showed simulation of conveyor systems, and what I showed is actually really, really good if you wanted to simulate your sequence, to test your code. Is the code of my sequence correct or not? So this where Simmet would be great. But if you want to test the physics of things, and things like, is my box going to follow the conveyor if I go too fast? Is it going to start spinning? Is it going to be hitting other boxes? What about the heights? Is it going to fit under something else? Or maybe you actually have 2 conveyors and you want to see what happens if you use a robotic arm to move it from one conveyor to the other conveyor. This is where MCD would be great. So again, what is your problem? Tell me your problem, I will tell you the solution and the package that solves it better. But it just depends.
Yeah,
Cool.
just to add on to that, on MCD, we can have the manual interaction as well. So while running, I can move the boxes around, for instance, on the conveyor. So I can generate certain alarms to see how that would react.
You could actually knock one off with your hand, can't you?
Knock stuff out. I can also introduce different products. So for instance, I want to introduce a faulty product or a faulty box that looks slightly different, and I want to identify what happens to rejections, for instance.
Hey, I can do the same with Simmet. Don't be like this.
Yeah. Is there any questions from the wider participants? If anyone wants to unmute their microphone, they're of course welcome to ask a question. Otherwise, I'll continue with another one I received on LinkedIn last night.
Hello, James. I have a question.
Go on. Yes, Gary, go ahead.
Just the tip portal add-in that we seen earlier.
Yep.
I'm familiar with some add-ins. There's ones for converting FCs to FBs, for example. I've seen that, but on browsing the COF site, I was unable to find this add-in for the model creator for Simmet. Is that something that's available or something that's being developed internally?
Top secret.
Okay. It's being developed. It's released internally, and for customers, it's going to be released very soon.
Yeah, okay, that's great.
It's all ready for you, Gary. The only problem is, like we always need to include the documentation, to go through everything, to make sure that you know exactly how to use this. The documentation isn't ready. So the programmers, they love programming stuff, but then, they need to write documentation, and this takes the longest. So as long as this is done, it will be released on Sires, and just stay tuned, it will be there for you.
No, that's great. That's great. Thank you.
Thanks, Gary. Any other questions from the crowd? Okay. I'll ask this one about robots, because this gentleman contacted me yesterday about it. And we showed robots in MCD Anubhi. We also have Process Simulate, which simulates robots. What requirements would I need for picking which package to go down the robot simulation route? What am I trying to achieve? What problem am I solving? What are my pain points?
Right. So if you just wanted to test how your controller is interacting with the robot, so you want to have a start point and an end point, and you want to make sure your sequence is being followed correctly. You're not much bothered about how the robot arm is actually moving. the actual interpolation or the movement of the arm, then MCD is fine. And if you're limiting to one robot, maximum of two. But if you have a cell that has, say, 3 or 4 robots, and you're also interested to know, so you want to define it's a KUKA robot, and you want to define that that's how it should be moving, and you also want to write down your own code, then it's process simulate. So what the main differentiator is, if you want to write down your own code and you want to test exactly how the robot is moving, it would be process simulate. But if you just want to test your sequence and your integration of your controller with your robot is correct, the sequence follows, it says robot, you do that, it does that, gives the feedback, and my controller continues with the sequence, then it's MCD. And why we can say MCD is a subset of process simulate. So most of the things that process simulate, MCD does, process simulate does, but it's the cost difference. So obviously process simulate is much more expensive than MCD. So again, as Michael said earlier, we have to identify the application, what we really need to achieve out of it.
I think just to add on Anubhi's point there as well, the big differentiator with process simulate for robotics is a lot of pre-defined objects you can drag in. So like Anubhi said, there's a lot of robot vendors who have shared their CAD models for the robots. Now the big thing that process simulate will do that MCD won't is the limitations of movement. So the different axes of robots, it will tell you whether it can move there or it can't move there. It'll highlight the joints to say if there's excessive strain on those different parts. And you can also use process simulate to generate some code that can be put straight into the robot controller. So as Anubhi said, if you don't really care what the robot's actually doing and it's just mainly the PLC code, it goes from A to B, how the robot does it, I'm not interested, MCD all the way. If you're interested in the robot control and what it's doing, then process simulate. The other big differentiator between the two as well is MCD will simulate gravity, but the process simulate will not. So if you're looking at how it's going to be handled in terms of moving that item, then again, it's a bit of MCD in there.
It's a good point actually, and which is around material flow. It's much easier to configure material flow in MCD, having the sources and the sinks compared to process simulates.
Cool. In that case, if there's no questions, I want one final question, because everyone always talks to me about this one, where they say about digital twins and they see cool things at trade fairs. They see VR headsets, AR technology. Where do you guys see this fitting in terms of the Siemens virtual commissioning piece and digital twins moving forward? What is the future for us with this?
If I can really quickly jump in at the front of that one, James, when yourself and I went to Ireland a few years ago, we met a customer that was using our 3D modeling software. So using MCD, you can create a VR experience. And what they were doing, this company, was they were building bespoke small pieces of machinery, and they were using the full VR experience to train the maintenance staff on maintaining this machine. So when we went in, it was quite amusing. They had people lying on their back, wriggling around on the floor. So when you looked at them, it was very surreal. But when you looked at the screen, it was actually someone lying under the machine to see if that particular terminal box was accessible. So for anyone that's actually worked on machinery will appreciate that the guys that are designing it don't always think, can I actually get to that terminal box if I need to replace something? So for me, the thinking ahead to the maintenance and is it possible to operate the machine in that factor is a great thing with the VR.
Yeah. And
I honestly think that we can actually do all the commissioning and so on with current systems. We don't need VR for it. But VR comes into play when it's all about human interaction. So things like Nick mentioned, can I operate the thing? Is it going to make sense? How will it feel for me actually? This one thing. The other thing is, once it's actually commissioned again, we go back to the training. And training a guy, in a VR environment is going to be next, the closest to the real thing as it can possibly be. We can put him in VR goggles. We can actually embed unified screens in his simulation, so he will be.
WinCC unified, Michael. Let's clarify. People might not know what unified is. There's HMI screens, operator screens.
WinCC unified, our latest and greatest visualization system, which runs in a web browser, which is why it is that easy to just take your screen and embed it in your AR environment for testing purposes, for training purposes as well.
Cool.
I guess the one more thing with the augmented reality on that point, Is for me, the other powerful one is when you're knocking together like a general arrangement. So you've built a new factory, you've got a very large concrete empty floor, and you're trying to work out where you're going to put your machinery. Where does the machinery need to go? What's going to give you the best flow through the shop floor? So being able to sort of maybe stand on a gantry and look down at the complete overall empty shop floor with a set of augmented reality goggles on. I can still see the shop floor, but in my periphery, I can move around the different 3D models, which are going to go together to lay out my shop floor. So I think augmented reality is a powerful one for that.
Cool. Cool. We will end on the futures unless anyone has any open questions from the crowd. But,
Well, for me, James, because it's a question that I got from 3 different people on LinkedIn yesterday or the day before. Everyone was asking, can I actually, integrate these things? Well, they were asking mostly about Simmet, but I guess it applies to all of them with some third-party controllers. And I think people are a bit worried about asking these questions here in open forum because they are like, yeah, these guys are selling Siemens equipment. They want me to use everything Siemens end-to-end. Sure we do, but it doesn't mean that we are just, rejecting the opportunity to also maybe, just integrate with some third-party equipment, show you how Siemens is greatest, and then you can go with Siemens end-to-end solution. So is it possible? I would say, 3 products that we showed you, it is. So PLC Sim Advanced could and is actually talking to third-party other, simulation packages. Simmet, it has OPC UA, OPC DA, and it actually has a Simmet unit, which is like a hardware unit, so it can even talk to hardware. And then MCD with its couplings, again, it can talk to third-party equipment. So don't be worried that it's only Siemens end-to-end solution. You can embed your bits from third parties inside. And then when you will see the benefits, you will see the way.
Yeah, all 3 of those can do OPC UA. And with the Industry 4 topics, OPC UA being the way forward, you can integrate with third-party bits of kit by using that mechanism pretty easy because they've all got the native channel drivers.
Of course, though, if you're using a third-party PLC, if a process takes 8 hours, you'll have to wait 8 hours. Whereas with PLC Sim Advanced, Simmet and MCD, you can make 8 hours be 8 minutes. So, those are the differences. Good. Thank you, guys. We're approaching the hour, so I will draw this session to a close. A big thank you to everyone who has joined us for the complete series of Digital Twin Talks this week. We're back on a repeat at 2 p.m. if you want to come see us again. Cybernet Week is up next week. There's some great topics. Our process automation stream is fully up and running next week. In fact, Simmet is being shown next week as well, but from more of a process automation feel as well. But for now, a big thank you and a big goodbye. And we look forward to seeing you again